Okay, so today we're going to talk about shortest paths when you allow edges to have negative weights. And this seems innocent enough, right? What's the big deal? So let me first, since this is a theory class, let me formally define the problem and give you a directed graph as usual. And in this case, by the way, the fact that it's directed would really matter because the undirected version is significantly harder. So we're given a graph, we have edges, every edge has a length. The length is now a real number, it can be negative. And given two vertices, S and T, we would like to find the shortest path between them. Or starting from the vertexes, we would like to find the shortest path from A to all the vertices in the graph. In this case, for example, I believe the red path is the shortest path from S to T. And as you can see, you pay 9, 10, then minus 16. Right, so 3 overall and 16. So the length of the red path is 19. Right? Okay. Now the question, of course, is we know, we have one algorithm that already works for shortest path Dijkstra. So the natural question is, well, why can't we just use Dijkstra in this case? And it's very easy to see that the Dijkstra don't work. Just consider this example. I'm going to run through this example shortly, but if you want to do it yourself, you should probably stop the video now. So let's see what happened. And for some reason, I animated it in the past, so I should be forgiven for doing this. Okay, so S is 0, then the path goes to 1, so it's going to be 1, right? Because we're always going to the cheapest candidate. This is going to be 2, then 1, so we get a path of length 3 from S to W. But now we are going to go to X because it's 5, right? It's the next one to be scheduled. And then we get 5 minus 5, we get 0, which means that the weight we assigned to Z was the path we assigned to it, and for the short path we assigned to it was wrong, right? And that's the problem with Dijkstra. Dijkstra never looks back, right? It's very confident what it does. It just do it, never backtrack, never doubt itself. Just go ahead and set distances. But when you have negative edges, it just doesn't work. Okay, so it's natural to ask what's the bug, right? What property of shortest path did we use that no longer hold? And the important thing is that it's no longer true that the length along the shortest path is monotonically increasing, right? Because you go, this is 5, and then you go down this edge, it's minus 5, so it's 0, right? So the length of the path along the shortest path increase and decrease, which is a big problem because that means that the scheduler, right, can't schedule things in increasing fashion because things might appear later on. Things that appear later on you had to schedule them earlier on, and this is a mess, right? Which means that the Dijkstra is just not going to work, and not only it's not going to work, it's not easily fixable, right? So, and by not easily fixable, I mean it cannot be fixed. There are certain special cases where some variant of the Dijkstra work, but in general, the Dijkstra just does not work for this case when you have negative edges. So we need a new algorithm.